Hello and welcome to a nostalgic math ramble. Today we are continuing to look at IEB's paper 1 from May 2024, and today we are focusing on question 5a, which is a counting question. So let's see. In a shop there are 6 unique dresses. Wow. Okay, so there we go. 6 very unique dresses, very colorful. In how many ways can the 6 dresses be hung on a rail? Okay, so this is a very simple, the most simple counting scenario, right? Where we're not considering constraints like, these two have to be next to each other, or we want to select 3 from the 6. How many ways is that possible? Like, this is the most straightforward counting situation, right? So your first order could be 1 2 3 4 5 6, or it could be 1 2 3 4 6 5. That would be a new order. Or you could have 6 5 4 3 2 1, right, and so on. So it's really, you can order them freely. And so the way that I always like to think about these questions is, okay, how many slots are available in whatever arrangement I want to make. In this case, there are 6 slots on the rail, right? Because we want to hang all 6 dresses. Then the next question is, okay, for the first slot, how many options do I have? I'm going to have 6, right? I can choose any of these 6 dresses to put in the first slot. But then now for the second slot, how many dresses will be available? It will no longer be 6, it will be 5, because I've already chosen one to hang here. So then for the second slot, I'll only have 5 options left. And by the same reasoning, for third slot, I'll have 4 options, then 3, then 2, and then the last slot will be obvious. There'll only be 1 dress left for that slot. So then how we then calculate how many arrangements are possible is we say it'll be 6 times 5 times 4 times 3 times 2 times 1. All right, in other words, 6 factorial. And I think that is 720. So 720 arrangements are possible. Next question. If dress 1, dress 2, and dress 3 are hung side by side on the rail in any order, so it could be 1 2 3, it could be 1 3 2, could be 3 2 1, in how many ways can the 6 dresses be hung? Okay, so now we're introducing a constraint, right? Dresses 1 2 and 3 have to be next to each other. The order doesn't matter. Well, the order does matter in terms of each order makes a new arrangement. But yeah, okay, so they have to be hung side by side. It doesn't have to be 1 and then 2 and then 3 is what I mean. So then how we can think about this is, we now have this unit, which is dress 1, dress 2, dress 3, and we'll come back to the dynamics inside the unit. But for now, let's just look at it as one unit. These cannot be separated, they have to move together. Then the remaining dresses will be 4 5 6. These ones can move around as they please, right? So I'm just gonna call this big B for block. Okay, so this could literally be one of the arrangements. Oh guys, what's happening? This could be one of the arrangements, or we could have 4 and then the big block, and then 5 and then 6, or we could have 5 over here, big block, 6 and then 4, right? So these are the different ways that we can, some of the different ways that we can move, we can arrange these dresses and honor the constraint that has been specified. So we now have 4 things that we're trying to arrange, right? Not the original 6. And so the question is, okay, how many ways can we arrange these 4 things? And that answer is 4 factorial, right? Because you could have 4 things in the first position, and then for the third position, second position, you'll have 3 options left. And then for the second position, you'll for the third position, you'll have 2 options left, and then for the fourth position, you'll have 1 option left, right? So 4 factorial is number of ways we can arrange B, dress 4, dress 5, and dress 6. Right, so now the additional thing that we need to consider is that for each of these arrangements, so let's say for this arrangement, for example, it could be 5, 1, 2, 3, 6, 4, right? Or it could be 5, 1, 3, 2, 6, 4, right? Or it could be 5, 2, 1, 3, 6, 4, right? So these are all creating different arrangements. So within this one arrangement, depending on how we order the dresses inside the block, that is also going to create new arrangements. So the question then is, in how many ways can we order these 3 dresses within the little block? And the answer to that is 3 factorial, right? Because we now have 3 slots. For the first slot, you have 3 options. It could be dress 1, dress 2, or dress 3. And then for the next slot, you have 2 options left. You know, it's whichever 2 dresses weren't chosen here. And then, of course, for the last slot, you have one option left, right? So this is a number of ways we can arrange 1, 2, 3 inside B. Okay, so now what does that mean for the number of arrangements possible in total? It will be 4 factorial arrangements, which is just telling us how we can arrange 4, 5, 6, and the block of 1, 2, 3, dresses 1, 2, and 3. But then for each of those arrangements, there's also now a 3 factorial number of ways that we can arrange dress 1, 2, and 3. So in total, we have 4 factorial is 24, 3 factorial is 6, 24 times 6 is 144. So there are 144 ways that we can arrange these dresses, and 1, 2, and 3 are going to be next to each other in whatever order. Okay, yeah, I've spoken with so much confidence, but sometimes these counting questions really do dribble me. So let's make sure that I have not spoken complete nonsense. Question 5a. So we have 720 for the first answer and 144 for the next one. Yay! I spoke sense. Woo! Okay, so that's it for this video. Catch you on the next one.